So in this portion of the recording, or in this portion of the lecture, I will be talking about multiple data providers in Web Intelligence. Data providers is nothing but a fancy name for queries. If you remember, when we started Web Intelligence, I mentioned that one Web Intelligence document can have many different tabs which are called reports, and at the same time, one Web Intelligence document can also have multiple queries. So far, we have played around with one query, but why do we need multiple queries? Let's just spend a little bit of time on the need for having multiple queries in one Web Intelligence document. So let me open Web Intelligence and I can show you. So when you create a query, let's say most of the times, and I can actually exit out and then start from the beginning. So when you start Web Intelligence and it says you need to create a document, it asks you to pick a source. So these are all the possible sources, right? So Excel file or Bex query or so on. Most of the times we either use Excel files or text files or universes as our source for queries. So let's say that I'm using eFashion Universe for one of my queries. And there is some more data sitting in a different database, and there was a separate universe created on that database. So if the requirement is that you need to have one report that combines the data from these multiple databases, that is a most likely reason why you would have multiple queries. So if I have, let's say, if I have a query on, let's say, eFashion, okay, and I run the query, I have this data. I go back, edit the query. You can see that I have an option to add another query. So if I say add another query, it asks me, do you want to add a query from a universe or an Excel file or a text file and so on. So one of the possibility could be that you are connecting to multiple databases and there are separate universes set on each one of the databases, and you create one query on one universe, you create a second query on the second universe, maybe a third query on the third universe, and bring all of that data into your Web Intelligence document, and then you merge the data inside your Web Intelligence document. So that's one possibility. The other possibility is that you have one universe which has majority of your data, but then somebody says, well, this has sales data, and I want leads or sales leads information incorporated with the sales data. Now, sales leads information sits in an Excel file. So then you will build a second query using an Excel file, and then you will try to merge the data from the universe and from the Excel file in the report. So that's another possibility. One other possibility, which is a rare possibility, is that you want data from only one universe, but for one of the reports or for some of the reports, you have to analyze the data at different level of granularity. So you may have to have very detailed data for one query and very aggregated data for another query, and then you have to merge them for whatever reason. So that happens as well. It's very rare. There were few circumstances in my career where I had to do that, but it's a possibility as well that you are going to use the same universe, but for specific reports, you may have to create a detailed query and a summarized query and then try to combine the information together in the report. So these are some of the most likely possibilities why would you need multiple queries. Now, the rest of the portion in the lecture is more mechanical in nature, which means I will show you the process of how do you create multiple queries and how do you merge information from these multiple queries inside the Web Intelligence document. All right, for the demo for multiple data providers, I'm going to use eFashion Universe, and I'm building a couple of queries with it. So the first query that I'm building has the year, state, and the sales revenue object. And then I'm going to run this query. And then I'm going back to data access, and I'm adding a query on the same universe. And then I'm going to use the year, all right, so I'm going to run the second query, and then when I run the second query, it gives me a message saying that you already have one query ran, so do you want to insert table in the new report? Do you want to insert table in the current report, or do you want to include objects without generating a table? So I don't worry about generating a table at the moment. I'll just pick this option. And when you have objects from both the queries in your report, everything is listed alphabetically, but I mean, it doesn't tell you which object comes from which query. So the first thing I want you to do is to, down here at the bottom, change the arrange by alphabetical order to arrange by the query. Once you do that, it's much more readable. So I can see that the first query has 2 dimensions and 1 measure, and the second query has 3 dimensions and 1 measure. Now, why is it important to know how many dimensions and measures are from each query? Because of the process that we are going to use, it's important for you to understand that the process to merging the data together requires us to do minimal work, or ideally we should do minimal work when we are merging the data together. So once you have the 2 queries or the data from the 2 queries in Web Intelligence and you sort them based on the query instead of alphabetical sorting, the next step is to merge the data from the 2 queries. And you typically merge the data from the 2 queries based on the data within a column in one query versus a column on the other query. So for example, I have the year object here in this query as well as in this query, right? So, and it's the same data. I mean, this has 2003 to 2006 data. This also has 2003 to 2006 data. So when you are merging the queries together, the important thing to note is you're not necessarily merging queries on objects with the same name. You are merging queries on objects which have same or similar data. So the merge happens on the data. Just like when you do a join, when you're writing a SQL statement, you are joining the 2 tables on the data. You're not joining the 2 tables on the column names, right? So keep that in mind. In this case, I'm going to use the year object to merge the 2 queries. Right now, the queries are not merged, so you can see that when I click on any object from the first query, all of the dimension objects from the second query are unavailable. So it's telling me that I cannot use these 2 in the same table here. So the first thing first, we merge the data. So to merge the data, we are in the data access tab, and there is this merge button. So you click on the merge button, and then you pick, you can hold the control key and pick objects from both the queries to merge. So I've picked the year object from both the queries, and I say OK. So when you merge the 2 queries, it creates something called a merge dimension, which shows you the dimensions from both the queries which are merged. And the combination of these, it creates an object which is called year. You can change the name of the object if you want to. But anyways, I'm going to keep it as default. So now I have merged the 2 queries. Now the next step is I want to display information from both the queries in one table in my report. So first of all, I'm going to get rid of this guy. I just want to make sure that I start fresh. So when you are ready to display the information together from both the queries in one table, this is where I want you to pay very close attention to what I'm saying. So at this point, understand which one is your bigger query. And what exactly do I mean by bigger query? What I mean by bigger query is that when it comes to displaying information together in a table, any measure objects from both the queries are going to be fine. You will not have any issues displaying the measure objects together in one table. Any merged dimensions are going to be fine. You won't have a problem displaying the year object from query 1 and year object from query 2 because they are merged. The problem comes when you have to display the unmerged dimensions together in one table from both the queries. So to determine which one of the queries is bigger, you have to see which one of the queries has the largest number of unmerged dimensions. So let's start with query number 1. This is a measure. I'm not worried about the measure. Even when I click on the measure, notice that nothing is disabled. This is a merged dimension. This is not going to be an issue. When I click on this, nothing from this is disabled. And this is a unmerged dimension. So when I click on it, you can see that these two guys are disabled. So query number 1 has one unmerged dimension. Query number 2. So query number 2, this is a measure. Everything is fine. This is a merged dimension. Everything is fine. This lines object is one of the unmerged dimensions, and then category object is the other unmerged dimension. So query number 2 has two unmerged dimensions versus query number 1, which has one unmerged dimension. So when determining which one of these queries are you going to use as the base table, pick the query which has the higher number of unmerged dimensions. So in this case, query number 2 has two unmerged dimensions. Hence, I'm going to pick all of these objects from query number 2 and display them in a table first, and then I will worry about query number 1. So I held the control key, highlighted all the objects, and I brought these objects over into my table first. Now I'm going to worry about query number 1. So query number 1, I told you measures from query number 1 is not a problem. I can display the measure here. Don't worry about the numbers if the numbers don't make sense. I can also display the merged dimension, but since the merged dimension is already here, there is no point displaying the year object twice. But when it comes to the unmerged dimension, notice what happens when I try to bring it in. What does it say? Cannot drop here. The object is incompatible. So it is not letting me drop the unmerged dimension from query number 1 in this table. Okay, everyone understands this? So this is going to happen with every unmerged dimension that you have. The reason why I chose query number 2 as the base table, because it has two unmerged dimensions, and whatever am I going to do to solve this state object issue, I would have to do it twice because there were two issues in the query number 2. So I picked the bigger query as my base table because I don't have to repeat the process 2 times. I would much rather do it once. So now everything else is there. I have to just figure out how do I put the state object in this table. So this is where we have to trick Web Intelligence. And how do we trick Web Intelligence? The process is that we create a variable for every unmerged dimension that you want to display in the table, you have to create a variable. And then in this variable definition, I'm going to call it, let's say, v underscore state. And for the content of this variable, I'm just going to pick the state object because that's what I want to display. But one thing that I'm going to change is, instead of making it a dimension, I will say make it a detail. Now, what is a detail object? A detail object is an object which is associated with another dimension. Okay, so when I change it to detail, it says, okay, which dimension object do you want to associate it with? And I'm going to pick, this is where you're tricking Web Intelligence. So I know that state object comes from query number 1, right? I'm going to trick Web Intelligence by saying that, oh, actually the state object comes from, and I'm going to sort it by the query. So I'm going to say the state object doesn't come from query number 1, it comes from query number 2. And I'm going to pick the merged dimension either from here, or you can pick it from here. I'm going to pick the merged dimension of query number 2 and say that this detail object belongs to the merged dimension of query number 2. Okay, so by tricking Web Intelligence and saying that this unmerged dimension from query number 1 actually doesn't belong to query number 1, it belongs to query number 2. The reason why you are having problems with displaying it is because it's saying, well, this is incompatible. Well, now, even though this is incompatible, the variable that I'm creating, I'm telling Web Intelligence it doesn't even belong to query number 1, it's belong to query number 2. So what is your problem? So validate this, say, okay, this variable becomes available just like any other objects are available. And then instead of using this state object, I'm going to use this v underscore state object. And then it's not going to create any problems. And don't worry about the multi-value. Multi-value is not an error message. All it's telling you that there are multiple values for this row. How do you want me to display it? Okay, so don't worry about that for now. There is a way I can, for some of the multi-values, I can get rid of the multi-values as well. But the important point is that it allowed me to display this information in the table, whereas it wasn't even allowing me to display this in the table, right? So the process that we followed for unmerged dimension is that we created a variable for every unmerged dimension that we have to display in the table, and then that variable is a detail object, and then you cross-link it. If this unmerged dimension comes from query number 1, you link it to query number 2. If it comes from query number 2, you link it to query number 1. And then the linking is done on the merged dimension of the other query. So that's how you basically trick Web Intelligence. Now, coming back to the original point, why did I choose query number 2 as the base table? I chose query number 2 as a base table because it had 2 unmerged dimensions. And for each unmerged dimension, I have to create a detail variable. So had I used query number 1 as a base table, I would have to create 2 variables. So you have to minimize the work that you're going to do. So that's why I pick the larger query. And when I explain the larger query, I explain that I mean pick the larger query in terms of unmerged dimensions, use it as a base table, and then pick the smaller query in terms of unmerged dimensions, and then bring the measures and the merged dimensions, and then for every unmerged dimension you have to create a detail variable.